Hello, everyone. This is the lecture for section 1.5, integration by substitution. So at this point, we've already built up enough of the theory to start moving into some more sort of semi-advanced integration techniques. The very first one that you should have learned at the end of Calc 1. If you didn't, it's okay. We're going to cover it right here. The first one that you should have learned at the end of Calc 1 should have been uh, uh, integration by substitution. Okay, so let me go over what the reason for it is, right? And then we'll, try some problems out. Okay. So first of all, what I want everybody to take a look at is I want everybody to consider this function right here, this one right here in particular. F of x is equal to 2x squared plus 5x plus 1 quantity to the fifth power, right? If we wanted to take the derivative of this, right, then the derivative, and I'll let you guys try it out for yourselves, should be this thing. And the way that you would do it, right, is by chain rule, right? So if we know that this is the derivative, right, and the integral undoes the derivative, right, then we should have this statement right here, that the integral of f prime, right, should be the integral of our big, huge, nasty derivative that we found, right? And we know it's supposed to undo it, right? So we should get back our original function, right? Plus a quantity c, because all of these things sort of differ by a constant, right? Okay, so that's the idea, right? The idea here is that if you took the derivative, right, the integral should undo it. Yeah, so we should get back our original, okay? Our original function f of x. But the way that we got our derivative was by chain rule, right? So that's the point behind U substitution. This is sort of, U substitution is an integration technique that sort of undoes a derivative that was found using chain rule, okay? So let me go ahead and do the very first of the theory here. Let me give you guys the definition first. So the idea here is that suppose you have an integral that looks like this. Essentially, what you're saying here is that the integrand, the thing that's inside the integral, right, contains some version of the derivative of something else that's in there already, right? And the idea is you would let that g of x end up being that u, right? And then you take the antiderivative, you take the integral of the simplified version, and then at the very end, right, you undo the substitution, okay? That is integration by substitution, at least for indefinite integrals. We'll get to the definite integrals down below, okay? So there is a strategy to how to find these, okay? And this is the one that I believe is in the book. I think I might have added a couple more steps here and there, but it's all the same, okay? The first thing that you would want to do, right, is carefully look at the integrand, right, and select an expression of g of x, okay? You're going to be looking for that expression, g of x, such that, right, a version of the derivative of g of x, so some version of g prime, okay, is also somewhere in the integrand, okay? And that's the thing that you're going to let be the u, right? You have to take the derivative of the u, so that's where we get the du dx, right? Perform the substitution. That's going to be step 3, right? Evaluate the integral with the simplified u in there, right? Evaluate that integral. And then at the very end, you undo the substitution. You undo the substitution at the very end, okay? So let me go ahead and do an example so you guys can see what I'm talking about here, okay? So if we take a look at this integral, right? We are trying to look for an expression somewhere in that integral where the derivative is somewhere else in there. Does that make sense? Okay. And for this one, right, the easiest thing to go for, right, is if we let u equal to x squared plus 1. Okay. So if we let that be u, then we are going to The next step we're going to do is going to take the derivative, right? So du over dx is going to be 2x. Sorry, yeah, that's it. It's going to be 2x, right? I'm going to rearrange this so I can get x dx by itself. And there's going to be a reason for it, okay? So I want to get x dx on its own here, right? So I'm going to multiply both sides by dx, multiply by dx. So I'm going to get du is equal to 2x dx. And I'm going to divide by 2 here. So I get du over 2 is equal to x dx. Okay, so now this might look a little weird, like why did I do that? I'm going to show you guys why right now. I'm going to go ahead and look at the original integral. I'm going to rearrange stuff, okay? So if I rearrange stuff here, I'm going to get the integral, right, of x squared plus 1 quantity squared times x dx. Now I have this x dx here that I'm going to be doing the substitution for. So now I'm going to use these two things in particular, the u and the du over 2, x dx bit. That's what's going to be the substitution that I'm going to do for my integral. So then this is going to be now the integral. X squared plus 1 was u, so this is going to be u squared times x dx. That's what we solved for here. So it's going to be equal to du over 2. So times du over 2. Okay. And now I get to play around with this integral. So there's a du over 2. So there's a 1/2 here. I'm going to go ahead and filter that out up front. So it's going to be 1/2 integral u squared du. And now looking at this thing, right, that is a much simpler integral to perform. Okay. And if you guys remember, for those of you that were able to go through it, it's going to be 1/2. So the rule here is you add 1 to the exponent and then divide it by whatever that number is, right? So it's going to be u cubed over 3, right? And since this is a indefinite integral, I have to add my plus c constant at the end. All of the antiderivatives or the indefinite integrals, right? They differ by a constant. Okay. And at this point, now I get to undo my substitution. My original substitution was u is equal to x squared plus 1. So I'm just going to go ahead and undo that. And I'm going to do a little bit of multiplication here. So it's going to be x squared plus 1 cubed all over 6 plus c. And there you are. Okay, so now I'm going to check it by differentiation, aka we're going to go backwards. So the idea here, right, is that if I take the derivative of this, I should get this original thing at the end, right? So let's go ahead and take the derivative of that thing in the green there, right? So x squared plus 1 cubed, I'm going to put a check here, over 6, right? Plus c, I want to take the derivative of this, right? Okay. The derivative of a constant, that's 0, so that c ends up going away, right? So all I'm going to get left with is the derivative of this thing, the x squared plus 1 quantity cubed divided by 6. That's what I'm that's what I'm going to get left with to differentiate. Okay, so the derivative of this is, like I said, it's chain rule, so it's going to be 3. The derivative, when I do chain rule, right, I do the outside, leaving the inside alone. So this is going to be 3 times x squared plus 1. Since I brought the 3 down, it's going to be minus 1. So it's going to be 2, right? All divided by 6. And then it's going to be times the derivative of the inside, which is going to be 2x. So the derivative of x squared plus 1 is going to be 2x, right? So I'm going to extend this a little farther. I get to simplify here. So I'm going to have the 3 and the 2. They multiply on top. That's going to be a 6x times that thing, x squared plus 1, all divided by 6. And I have a 6 on top and a 6 on the bottom. So I get left with x squared plus 1. And I forgot a square here. I forgot a square here. but we got it. That is equal to that. Okay, so that's a good way to sort of double check your indefinite integrals and your definite integrals once we get there. Take the derivative of it. It should be the original that you started with. Okay, so if that happens, then that means you did the procedure correctly. Okay, let me do another one. Okay, compute the indefinite integral of this thing. This should look familiar again, right? So again, I'm going to do the u is equal to the x squared plus 1, right? I'm going to go ahead and take the derivative of this, right? So it's going to be du over dx. Let me write that nicer. Du over dx is equal to 2x dx. I'm going to rearrange everything again. I'm going to get the same thing from before. So du over 2 is equal to x dx. I can rearrange this thing as much as I want, okay, in order to perform the substitution, right? So this is now going to be the integral 1 over square root x squared plus 1 times x dx. Okay, again, we're going to use the u and the du over 2 to substitute in here. So it's going to be the integral of 1 over the square root of u x dx. That is my du times du over 2. I have that half in here again, so I'm going to filter that out. 1/2 integral 1 over the square root, 1 over the square root of u times du. Okay, and I'm going to rewrite this so that it looks like something that I can integrate using one of our rules. Integral, the square root of u is u to the 1/2, and since it's on the bottom, that's going to be negative, so it's going to be u to the negative 1/2 du, and I forgot to change that to a du, so it's my bad. Okay, now this right here is a much simpler integral to handle. Okay, we can use that the exponent rule for integration, where we add 1 to the exponent and divide it by the add 1, right? So that means this is now equal to 1/2 the integral of u to the negative 1/2. So it's going to be negative 1/2 plus 1 gives us a half. So it's going to be u to the 1/2, right? Actually, let me make it a little smaller. U 1/2, and it's going to be divided by that exponent, right? So 1/2 there, right? Plus c. I can clean up a little bit here. That cancels that there. So this ends up being equal to u to the 1/2 plus c. And now I can undo my substitution. So it's going to be the square root of x squared plus 1 plus c. Okay. So again, I'm going to double check it, right? So I'm going to do a check. We'll check. E-C-K. So I'm going to go ahead and grab the square root, well, x square root, x squared plus 1 plus c, take the derivative, right? Okay, the derivative of a constant, again, is 0. So that plus c at the end sort of lops off. We don't have to worry about it. I'm going to rewrite this a little bit. It's going to be x squared plus 1 to the 1/2, right? And this is the derivative I'm going to be doing. Remember, this is all based off of chain rule. So this rule to take the derivative of this is going to be chain rule. If you guys remember, that means you drop this down and then minus 1 by this, right? So it's going to be 1/2 x squared plus 1 to the negative 1/2, because it's going to be 1/2 minus 1. That's where we get that thing, right? Times the derivative of the inside, 2x. Okay. I can simplify some stuff already. There's a 2 up front. There's a 2 in the back, and that's going to cancel out the 1/2 that's up front. So I get left with, I'm going to bring the x up front as well. So it's going to be x times x squared plus 1 to the -1/2. And if we recall from pre-calc, the square root is to the 1/2, right? And then the negative brings it underneath. So we're going to have x on top divided by the square root of x squared plus 1. And lo and behold, right, the derivative that we got goes right straight back to what we started with. Okay? Cool. This is going to be the first quick check for this section. Make sure you work it all out. Don't skimp on any steps. Take them all slow, right? Write everything down. You don't want to mess up on a substitution, right? Because in the future, in a couple of weeks, we're going to be doing multiple substitutions. You don't want to confuse yourself. Write it all down, okay? Don't skimp out on the steps, all right? Go ahead, complete this. You can pause the video here. I'm going to keep going. There are certain expressions, there are certain integrals where you can do them by substitution, okay? But you sort of have to coerce them into it a little bit. You have to do a little bit more math and magic to get it to work out, okay? And this is one of them, okay? So what I want to do here is I want to show you guys how to do this, okay? You're going to see sort of the manipulations. Nothing that I'm doing, right, is a sleight of hand. All of this is completely sort of legit mathematically, okay? So let's say I wanted to take this integral right here. It doesn't look like I can use u substitution, right? As it stands, right? But I can modify it a little bit, okay, so that I can use u substitution, okay? These are a little tricky, so just keep an eye out when you get them for your online homework or in the lecture questions, okay? So the first thing I'm going to do for this one is I am going to do this. I'm going to say that this is the integral of x times x squared times x squared times the square root of 1 plus x squared dx, okay? This probably looks like, why the hell did you do that? It's all a means to an end, okay? But now I'm going to go ahead and start using the u substitution portion, okay? And that's going to show up when I group these together. So it's going to be an x, and then I'm going to have this be the u. And so I'm going to still have that x dx sort of floating around, okay? So I'm going to go ahead and get started. I'm going to say that u is equal to 1 plus x squared, okay? Because I made this sort of assignment here, right? I get to play around with this expression, right, to get different other expressions that will help me out in my substitution. In particular, I can do this. I can do -1 on this side, right? And I get this expression. U minus 1 is equal to x squared, okay? And now you guys see, hopefully you guys see, that that's going to probably go in there and go in there, okay? I'm going to keep going with the u substitution sort of procedure from this point right here. Let me get rid of those. So if this is u, right, then du over dx is going to be equal to 2x dx. Whoops, 2x, sorry. Right? And then I'm going to rearrange everything again. I'm going to get a du over 2 is equal to x dx. Okay? Now I have everything for the substitution. So this and this and this, all three of those are what I'm going to use for the substitution. Okay? So like I said, keep a track of everything. Okay? It's all there. I'm going to go ahead and start doing the substitution here. Integral. Okay? I'm going to rearrange this one more time. Okay? I'm going to leave the x squares up front, but I'm going to grab the x from up front, throw it in the back. So it's going to be x squared times x squared times the square root of 1 plus x squared times x dx. And now I'm going to perform all these substitutions. So x squared is u minus 1. So it's going to be the integral of u minus 1. There's a second x squared, so it's going to be u minus 1 again. 1 plus x squared, that is u. So it's going to be the square root of u. And then x dx ended up being my du over 2. So times du over 2. Okay. This all turns into the half. Like I said, I'm going to filter that out. So it's going to be 1 half outside times the integral. If you perform the multiplication here, this is a bunch of pre-calculus. So I'll leave it to you all to sort of make sure that it works out. If you multiply this out, you are going to get u to the 5 halves minus 2u to the 3 halves plus u to the 1 half du. Let me write that properly. Okay. So notice, as it started, right, at the beginning, it didn't look like we're going to be able to use u substitution to perform the calculation, right, to evaluate this thing. But with all of this sort of manipulation here, it was all completely algebraic manipulation with a little bit of calculus, right? We're able to finagle it enough so that we can use our u substitution rule. And this is what the result is. Okay. This is much easier to integrate. Okay. So if you guys remember how to integrate this, right? I can integrate each one separately now, right? Times the 1 half up front, right? So this is now going to be equal to 1 half, right? The integral of this thing, right, of u to the 5 halves is going to be u to the 7 halves divided by 7 halves, 7 halves, 7 halves, 7 over 2, right? Minus 2, the integral of u to the 3 halves is going to be u to the 5 halves over 5 halves plus u to the 3 halves over 3, whoops, let me make that a little smaller, 3 halves, right? Plus c. Okay. And so at this point, we've already completed the integration, the calculus part, right? At this point, all we got to do now is undo that substitution from the beginning, that u equal 1 plus x squared, right? Okay. And I'm going to do a bit of reducing of the fraction so it doesn't look like it's a fraction of a fraction of a fraction. Okay. So I'm going to leave the 1 half out front, right? But this thing, I'm going to change it to 1 plus x squared to the 7 halves, right? And since the 7 halves is on the bottom, that's equivalent to 2 on top divided by 7 on the bottom. Minus 2. I'm going to go ahead and do the math for that one, simplify that fraction. It's going to be 2 on top, right? Times 1 plus x squared to the 5 halves divided by 5, right? Plus the last bit, 1 plus x squared to the 3 halves, the 3 up, sorry, the other way around, 2 up front, divided by 3 plus c. So I'm not going to go ahead and do the check for this one. But if you still are unconvinced, you should do it. You should go ahead and take the derivative of this thing and make sure that this is the original. So if we take the derivative of this, then we should get this at the end. Okay. Okay. Okay, there we are. So what comes up now is your next quick check for this section. Okay. All of these for everyone here. Okay. all of these require some finagling like this, okay? Requires some movement of stuff, requires playing around, in particular, this thing right here, this. It'll require playing around with your substitution to get other expressions, okay? Okay. Again, don't skip on the steps. Make sure you show every single substitution. Make sure you show every single derivative, okay? Moving on. Now I get to show you guys the integration by substitution with definite integrals. So now we actually start looking at areas under a curve, okay, from an interval A to B, okay? And the idea here is still the same from before. So if you have an integral, this looks complicated, and part of it is just notation, so you guys can understand the notation here, okay? Suppose you have an integral from an x equal a to x equal b, right? Then you can perform the substitution just like we did before, right? But when you change the variable, when you do the substitution into u, right? Then you can change the limits of integration as well, according to your substitution g, okay? And the way that we evaluate it, right? It's still going to be the antiderivative of u, right? If you keep the substitution, it's going to be at the two newly found endpoints, right? And if you undo the substitution, right, here's where the undoing of the substitution is, right? Then the evaluation becomes from the original limits from x equal a to x equal b, okay? And that is basically all this stuff back here. Okay, there's two processes to do it. I think by and large, everybody decides to undo the substitution and then evaluate at the original x values. Okay, so as an example, right? I'm going to go ahead and do this one. We already know that this integral, right? This was the very first integral that we did in this lecture, right? We know that this is going to be x squared plus 1 cubed all over 6, right? But now we get to evaluate it at our limits of integration. So it's going to be -1 to 3. Okay. Just how this thing states, right? I can go ahead and do the top one. It's supposed to be the top one minus the bottom one. So this is going to be 3 squared plus 1 cubed all over 6. Okay. Minus -1 squared plus 1 cubed all over 6. So it's going to be the top one, right, which is this one, right, minus the bottom one, which is this one. Okay, if we do the math for this one, 3 squared is 9 plus 1 is 10, so this is going to be 10 cubed over 6 minus 2 cubed over 6, and this is equal to 992 divided by 6, and if you needed to compute this out, 165.33 bar. Okay. As before, I provide you guys a Desmos calculator that solves indefinite integrals so long as you give it everything, okay? So let me show you guys the math there. So if you go ahead and, if you have your phone free, right? Grab your phone, scan that QR code, and it should pop this up for you. Okay, and let me make everything a little bit bigger there. There we go. Okay. This is the definite integral calculator that you can use while doing your homeworks. Okay. I'm going to go ahead and spread this out a little bit, make this a little wider here, and then I'm going to scrunch this up here. There we go. Yeah, right there. And let me, okay, there we go. So the idea here, right, was to find the integral. Let me go back to the notes. From -1 to 3 of x times x squared plus 1 quantity squared, right? And our answer ended up being this right here. 165.33, right? So if you go to your calculator, if you go to the Desmos calculator, go ahead and change the function, right? Just change this f of x equal, right? And this thing will compute it for you, okay? And in the future, right, if you want to use this more often, you can move the a value around and you can move the b value around. It'll find the answer for you, um, depending on where you leave the a and the b, right? And we wanted it from -1, right? So I'm going to go move my a to -1, and my b was 3. So I'm going to move that to 3, and I get 165.33, and lo and behold, that is exactly our answer. Okay. Okay. And I believe after that, it is done. We are done. Okay. So at this point, go ahead, try the lecture questions. You can come see me in the math lab, or in the math tutoring center, sorry. I have my office hours there from 11:30 to about 1 o'clock in the afternoons, Monday through Thursday. And for this class in particular, I have an all-day Friday thing, okay, where I'm on Zoom, okay. If you guys got trouble, if you guys are still unsure, if it still feels weird, let me know, okay? Come visit, okay? Besides that, I'm done here. Happy studying.